As we head into the final days of September, you might be hearing some chatter in the weather community about a significant and abrupt change on the horizon: Arctic invasion, pattern flip, a dramatic shift in temperatures for a large portion of the United States. After a period of unseasonable warmth, the atmosphere seems poised to rearrange itself. Very cold air bottled up in the Arctic could soon be dislodged and sent plunging southward, bringing an early taste of autumn or even early winter to millions. So, what exactly does an Arctic invasion entail? A powerful surge of extremely cold, dense air originating from the polar regions. Imagine a vast reservoir of frigid air held in place by strong, upper-level winds. If those winds weaken or shift, a gate can open, allowing that cold air to spill out and travel south into the United States. When you hear a meteorologist discuss an Arctic blast or a hurricane's path, they are almost always referencing the output from sophisticated weather models. In simple terms, these models simulate the Earth's atmosphere. They begin with the current state of the weather: temperature, pressure, wind, humidity, from stations, satellites, and balloons all over the globe. Then, fundamental physics and fluid dynamics calculate how conditions evolve over time, stepping forward in increments into hours, days, and weeks ahead. Think of a massive 3D puzzle. Each cell has its own variables and altitude. Supercomputers run trillions of calculations per second to build forecasts. Forecasters compare multiple models: American, European, Canadian, each built differently. Different methods produce different solutions, especially farther out in time. Agreement raises confidence. Divergence increases uncertainty. The atmosphere is chaotic. Tiny errors can grow into large forecast errors. The Atlantic hurricane season has showcased the challenges of forecasting. We saw two significant systems form and intensify. Major Hurricane Humberto, a true powerhouse, briefly achieving Category 5 status with ferocious winds. Warm ocean waters fueled it this season. Its path stayed far from the U.S. yet influenced broader steering currents. Meanwhile, Tropical Storm Alda struggled to organize. Early model runs even hinted at a southeast U.S. threat, especially the Carolinas. Interaction with Humberto and added wind shear made guidance tricky. As new data arrived, guidance shifted, pulling Alda safely out to sea. A revolutionary tool is emerging: artificial intelligence. Google DeepMind's approach learns from decades of historical weather data. When others showed a Carolinas risk, the AI consistently curved the storm well east. Over time, traditional models converged on that outlier solution. This success is part of a broader trend of AI skill in the tropics. More accurate, earlier forecasts give people time to prepare, and can save lives. AI won't replace physics models, it augments them, a hybrid future of forecasting. This September shows why monthly averages can mislead. On paper, many areas look close to normal, but it felt anything but normal outdoors. We rode a wild roller coaster of temperatures. Distinct cool periods dominated early on for central and eastern states, with crisp mornings and mild afternoons. A persistent trough allowed cooler Canadian air to spill south. Then, as if a switch flipped, the pattern reorganized. The trough lifted, a strong ridge brought a dramatic warm-up. Summer-like humidity returned, melting away earlier cool anomalies. That heat makes talk of an Arctic invasion feel especially jarring. Averages can hide volatility. Daily swings define our real experience. September's normal came from a battle between two extreme patterns. A useful reminder: the average rarely tells the whole story. Precipitation is becoming a story of two very different regions. A persistent storm track brings abundant moisture to the central U.S. round after round, soaks fields, replenishing late summer deficits. Upper-level flow wrings out copious precipitation. Totals of several inches are possible over the next 2 weeks, but the east, the mid-Atlantic and northeast, trends drier. Alda may brush the immediate southeast. Widespread soakings farther north fade. A downstream ridge promotes sinking, stable, dry conditions. Soil moisture deficits are already dulling fall color. Without a major pattern shift, drought may worsen, impacting water and fire danger. A tale of haves and have-nots. Fortune split by the jet stream. It all traces back to where the storm track sets up and where it does not. Looking at early to mid-October, two trusted models diverge. The European shows a brief backdoor front and quick warmth returning. The GFS paints a dramatic Arctic blast and a deeper, longer trough. A vast disagreement near the 10-day mark, a critical window. Often the truth lands between, or one trends toward the other. A pattern flip is a fundamental jet stream reorganization. The east's ridge breaks down as a deep trough unlocks Arctic air. Frigid air gains a direct pathway south. Rapid warm-to-cold flips follow. Expect 15-20+ degree drops in the first frosts in many inland areas. If the GFS verifies, the cold could dominate much of October. That affects heating costs, crops, and the timing of first snow in the north. Forecasting remains complex. Disagreements are common and healthy. AI is changing the game. Together with physics models, it sharpens guidance. Stay informed and check updates as models converge. Follow the National Weather Service and your local meteorologists.